Unified Diagnostic Services UDS Security Access Service SID 0x27. So Security Access Service ID 0x27, the purpose of this service is to provide a means to access data and diagnostic services which have restricted access for security emission or data safety reasons. So the diagnostic services for downloading, uploading routines or data into a server and reading specific memory locations from a server are situation where the security access is required. That means, in simple terms, the diagnostic tester should have access to some of the diagnostic server controls or reading data by exchanging a security mechanism between the tester and the ECU. The security mechanism will understand that there is an authenticated request is happening on the critical parameters of the ECU, and the ECU will allow the tester to read such data from the server, or it actually accept the request and send the data back to the diagnostic testers. These are the few requests where diagnostic tester can access with the help of security access. So for example, downloading and uploading routines into a server. So some of the IO controls of actuators, if you need to perform from a diagnostic tester, then the tester is expected to pass the security mechanism in the diagnostic server, and then it allows the diagnostic tester to perform such operations on the ECU actuators. The second thing is downloading and uploading data into server. So for example, if you want to write a new key assignment into some ECU, or writing some adjustment value, some adaptation value to different ECUs, or writing some wind data, engine data into ECUs, some serial numbers, all that requires downloading and uploading data into the server, or even flash programming of the ECU. These requires again a handshaking between the diagnostic tester and the diagnostic server, nothing but the ECU. The third one is reading a specific memory location from the server. As you can see, reading a anti-theft counter value because of how many theft attempts have been made in the vehicle. If you have such counter in any of the ECU, or a new key assignment value, or the reading back the old key value from the memory, or some customer specific service data from any of the ECU memory location. In this kind of situation, when you read from a specific memory location of the ECU, then the server requests and expects the diagnostic tester to pass through a security handshaking between the ECU and the tester, thereby it allows to read such data from the ECU. So what happens if we don't have such security access? Then improper routine or data download into the server could potentially lead damage to the ECU or any other vehicle component. If you do IO control without security access and you start playing with the components, then it can reduce the life of the component age, or even it might create a malfunction, or it may fail the actuators on the outside. So the securities are required to perform limited operation of such things. And The specific security mechanism in the ECU is called as seed and key algorithms, or you can say this is one of the mechanism of performing handshaking between the client and the server, the ECU. So in general, the client requests for a seed from the ECU. A seed is nothing but a value. That value is generated by the ECU with the help of the ECU algorithm inside the ECU. Then it calculates the key with the generated seed, and it sends back the seed back to the diagnostic tester with this dashed line pointing towards the client. In this particular security access service has two requests in order to perform the final SID request. So I'll explain that. So once the seed is available, a part of seed and key algorithm is available on the diagnostic tester, where that algorithm calculates the key based on the seed value received from the ECU, and that calculated key value is sent again with the help of a new request, and the request will be again verified by the ECU in the algorithm. Once this handshaking is successful, then the ECU allows the client to have the access, and the access been granted to the client in order to perform some operation as we discussed earlier. Either you can do IO control, read data, or write data like that. So this entire process is called as seed and key algorithm. So the highlight of 1 and 2 made here to explain you that there are two requests being sent. One is seed and other is key in order to perform the final requested operation in terms of security access SID. This table explains you the subfunction used along with the security access SID. 0x01 stand for requesting the seed. So as I previously the first request, once the seed is received, then the key is sent with the help of 0x02, and the send key request is sent. So this is highlighted in red color just to tell you that inside the ECU you can have multiple levels of security for read, write, and IO control programming like that. So assuming that 01 is entry level security, and 03, 05, 07 and so on might be a higher level of security within the ECU and map to different component or read write operations within the ECU, and these are calibrated with the help of OEM with the different variables inside the ECU based on the documentation provided by the tier ones. Or in software implementation, this needs to be considered when you implement different IO control options or read write operations or memory location access. Then you can multiple level of security that you can assign for each of the subfunction. And the last one is system supplier specific. This range of value can be used for any of the supplier specific security handshaking. This slide gives an idea about the different security levels possible with SID and the subfunction. So this is for the engine ECU from one of the way where it's mentioned like the unlock level 0, 1 makes the security access to level 1 entry level security access, and it's used for general ECU unlock for doing a variant coding adaptation, adjustments. And the second one, unlock level 03, makes the ECU security to access level 3 might be an next level of access in the ECU, and it's used for unlock the adoption values like IMA, idle speed adjustment, diesel particular filter adaptation values like that. And unlock level 5 might be the next level of security access to level 5, and this might be used for request seed programming functions. Might be used for reflashing the ECU or reprogramming the ECU. Unlock level 9A, it makes the security to access level 9, and it's again is a general issue unlike in newer issue emission standards Euro 6 onwards. And for any special function, this kind of unlocking mechanism or handshaking mechanism can be used. And one more is like unlock level BC, and this is also again used in newer emissions of Euro 6 onwards to unlock variant coding. So the highlight is here is that the ECU can be accessed with different level of security access and for each of the component and the data or memory location reading or ECU programming. This slide gives the overview of how the request message is formed. So the request message from the client start with the SID and followed by the subfunction, and the third thing is the security access data record. So the first SID value for the security access is given here, and followed by the subfunction. You can have 01 or 03, 05, 07 and so on. And the security access data record consists of two parameters. So one is the key parameter where once the seed is available from the ECU, then the calculated key parameter is sent with the help of the security key with the 2-byte value. And one more record is possible where you can send the address or the unique ID of the tester in order to ECU to authenticate that there is a valid tester is connected to ECU server. This is also one more record possible which can be sent along with the request message. So as we discussed previously, the first request message to the ECU, which consists of an SID, subfunction and security access data. The request access is SID is the value is 27, you see, and there is a subfunction of type security access type. So in this diagram you can see that 2701, this is nothing but the security access type, and this has been sent from the diagnostic tester to the ECU, and ECU receives the request here, and the ECU generates a seed and it calculates the seed value. Then the seed is sent as a positive response to the diagnostic tester. You can see here the value 67, is 27 plus 40 XID becomes 67, and the 01 is the request seed subfunction, and followed by 4 bytes of seed data is been sent back to diagnostic tester. Then once this seed is received on the diagnostic tester, there is a key calculation happening here. This is the algorithm which runs on the diagnostic tester side for security. Then it calculates a key for the requested service. Then it sends those key value along with a 27 service ID and the subfunction 02 here, and it adds the key along calculated key along with the request message, and then it sends the key back to the ECU. Once this has been received, then a positive response is generated after verifying the key in the internal algorithm of the ECU, seed and key algorithm of the ECU. Then the ECU is unlocked at this point if the calculated key is correct and the requested key is also verified with the key which is received from the diagnostic tester. So let us look into the details of the positive response message. So as we discussed previously, the request is 2701 and the response is 6701 with the seed value which is calculated by the ECU, and it's been sent back to the diagnostic tester for key calculation. And this is the step 2, and the step 3 is again once this this key has been calculated, then with the help of 2702 the calculated key value is sent back to the ECU, and once the ECU receives this key from the diagnostic tester, then it validates the key with the internal algorithm. Once it validates and it is passed, then ECU grants access to diagnostic tester with 6702. So this is the 4 steps of security unlock process. So to remind you that the first step is request for security access with a security access type, and once the security access type is seed request seed, once the request seed is sent to the ECU, then ECU sends back with a positive response of sending the seed back to the tester. And third step is again one more request from the tester to ECU with the calculated key, and fourth step is the verification of the calculated key with the generated key internally in the ECU. If it is passed, then the positive response as a fourth step is given back to diagnostic tester, informing that the ECU is unlocked to perform further actions. Okay, so we have seen so far what are the different positive responses, and in this slide you can see what are the different negative response codes. So 0x12 correspond to the subfunction itself is not supported. So 13 is incorrect message length or invalid format. 22 is conditions not correct, and 24 is request out of range, and 31 is security access denied, 35 is invalid key, and 36 is exceeded number of attempts. And this 36 is important that when a seed and key process happening, you are allowed to have few number of attempts to get into get the handshaking with the ECU. If the number of attempts are increasing, then the ECU locks itself for some amount of time, and it will not allow you to proceed with any new request. Then you should follow a predefined step to again bring the ECU into live and start this session again. And 37 is required time delay not expired. This is one of the function required in one of the control functions. So the next step is an example of how this security access is done for a given request. So for example, the request message is 2701, and the response positive the response message is 6701, and the seed from the ECU is 36 and 57. This is the first request and first positive response message for security access. And the next step is the 27 followed by 02, and C9 A9 is the calculated key based on these seed values. Once this is available, then the next positive response message is received from the ECU, that is 67 and 02, and the ECU tells that your session is diagnostic session, or the ECU session is unlocked for you to perform some required function that has been requested, followed by the security access. This is one of the scenario as we discussed previously. Step number 1, 2 in this at the end of step 2, the ECU is unlocked. For some reason, if the diagnostic tester again sending a request at the same security level, I said, the 01 level, if it is sending a request for requesting seed, then the response could be the 25 bytes followed by the positive response could be 00 from the diagnostic server, that means from the ECU, telling that already the ECU has been unlocked and you can start performing the required operation. If, so for example, if the security level when the ECU is unlocked and you are trying to send apart from 01 to 03 or 05 something like that, then you will have a negative response. It won't allow you to go to the next level, or it will throw the next level of seed here for unlocking the ECU for 03 level of security access and so on. So that's all on the security access SID, and our next session will be on communication control 0x28 service. Hope the information is useful and your time is well invested. Thank you and see you again. Bye.